Hello ladies and gents, today's video is going to be integrating with substitution. So if you think back to when we were taking derivatives, if we saw a really complicated, ugly one, we used the value u to plug in and make it look a little prettier. We're going to do the same idea here. Looking at this problem right now, this does not match up with one of our most common integrals. So we're going to analyze this equation a little bit, see if we can match anything up. Well, I know that if we take the derivative of 9 minus x squared, we get negative 2x. So I'm going to use our method of u substitution here. So I'm going to say u is equal to 9 minus x squared. That means the derivative of u is equal to negative 2x dx. So using that information, we can replace this stuff with the square root of u. Okay, because 9 minus x squared is u, so I'm going to plug in u for 9 minus x squared. And instead of writing negative 2x dx, I'm going to replace it with a du. And now that's much easier to take the derivative of. So we can say that's u to the 1/2. That means we have u to the 3/2 times 2/3. And now, almost forgot the plus c. Now we took the integral completely. I'm going to replace our 9 minus x squared in for u. So our final answer is going to be 2/3 times 9 minus x squared raised to the 3/2 plus c. Alright, now looking at this problem, this one is probably one of the ugliest problems I've ever seen in my life. We have the integral, we're trying to find the area under the curve of 6 raised to 2x squared minus 3 times x times the natural log of 6 dx. Whew. Good golly, Miss Molly. Alright, let's try and get this solved here. So just thinking it looks ugly, I'm going to try and do u substitution. I'm going to say u is equal to let's try and find something that matches up here. Well, we have 2x squared here. If we took the derivative of 2x squared, we'd be left with 4x. Okay, so that's kind of similar to x. So let's see if that works. So that means our derivative of u is going to be 4x dx. Okay, but in our problem, we only have an x dx, so we need to get rid of that 4. So I'm going to divide both sides by 4 now. Okay, now I can replace everything. This looks good. I'm feeling good about it. So I'm going to change the colors. We have 6 raised to the u times natural log of 6 times du divided by 4. So I just replaced our x dx with du divided by 4. I replaced our u, or our 2x squared minus 3, with a u, and now we're left with this. Now, this divided by 4 is a constant, so we're allowed to bring that out to the front. Okay, we have 6 to the u times natural log of 6. Well, thinking way back from the past, you know that if we took the derivative of an exponential, it would take the form as this. So the prime of 6 to the u is equal to 6 to the u times the natural log of 6. Our base raised to an exponent is equal, the derivative is base to the exponent times the natural log of that base. So that means the integral of 6 to the u times natural log of 6 is just 6 to the u plus c. Now we're going to replace our u. Okay. And there we have it. Okay, so The biggest challenge for this is trying to figure out what to choose for u and how to sub it in. So there you just got to try and envision in your mind and match up the u substitution with this derivative. So here I matched up 2x squared minus 3 with its derivative of 4x. I made that look like x dx. So that's the toughest part. The rest is just remembering what the derivatives are. Okay, for this integral, it's a little bit more straightforward. We have 12x squared times sine of 4x cubed dx. So we're trying to find the area under that curve. So right off the bat, it looks really ugly, but we can clean up using u substitution. So let's figure out what our u should be. So analyzing this equation, we want to find a term that matches up with its derivative that are both in this equation. So 12x squared. If we took the derivative of 12x squared, it wouldn't look anything like 4x cubed. But if we took the derivative of 4x cubed, it would look exactly like 12x squared. So let's say 4x cubed is our u. So that means du is going to be equal to 12x squared dx. And that matches up just perfectly with everything. So 4x cubed goes with 4x cubed. 12x squared dx matches up with 12x squared dx. And now I'm just going to replace everything. So it's going to be sine of u du. Now we all know that integral for sine is negative cosine. And now I'm just going to replace my u, and then we're done. Okay, so I'm going to give you a couple practice problems, but that should be it. Alright, try these problems out. I would do these two with u substitution. You could do this one with u substitution, but it's very doable if you just think about what it's saying and rewrite it a little bit. So just a hint, for this problem, I would say this is going to be your u, and you're going to do some algebra to make it look like x squared dx. I would say this is going to be your u, and you're going to make it do some algebra to make it look like just dx. And try and rewrite this one differently. See if it looks like one of the common integral rules. Okay. Good luck, and I'll see you in class on Monday.